Welcome everyone. In this video, we'll look at what happens to the arrangements of particles when a substance melts and boils. We'll then look in more detail at the structure and bonding present in two different substances. I'll show you how to use ideas associated with structure and bonding to answer an exam question explaining the difference in melting points of these substances. The question is taken from an A-level chemistry past paper. Details are in the description. Let's get started. First of all, let's take a look at the arrangements of particles in solids, liquids and gases. In a solid, the particles are close together and arranged in a regular pattern. This is sometimes referred to as a lattice. The particles vibrate around a fixed point. In a liquid, the particles are still quite close together, however they can move around each other at random. In a gas, the particles are much further apart and move quickly in any direction. Here's the question that we're going to look at. The table shows some data about the elements bromine and magnesium, and you can see we have some melting points and boiling point data there. In terms of structure and bonding, explain why the boiling point of bromine is different from that of magnesium. Suggest why magnesium is a liquid over a much greater temperature range compared to bromine. The diagram here represents bromine in the solid state. Bromine has a simple molecular covalent structure. Each bromine molecule is made from two bromine atoms that are bonded covalently. One of these molecules is highlighted in yellow. There are weak intermolecular forces between the molecules, van der Waals forces to be specific. When bromine is a solid, the intermolecular forces are strong enough to hold the bromine molecules in a lattice. Intermolecular forces can be overcome with energy by heating the substance. The molecules are no longer held in a lattice and the solid melts. It is very important to note that covalent bonds are never broken when a simple molecular substance melts or boils. It is intermolecular forces that are overcome. Now, let's take a look at magnesium in the solid state. Magnesium has a giant metallic structure. A lattice of metal cations is surrounded by delocalized electrons. Magnesium does not contain molecules in any state. When magnesium melts, strong metallic bonds are overcome and the ions are no longer held in a lattice. So far, we have described the structure and bonding in both bromine and magnesium. To explain the difference in the boiling point, we can state that bromine has a lower boiling point than magnesium because less energy is required to overcome the weak intermolecular forces than the strong metallic bonds. If we look back at the question, our answer is almost complete, but we still need to explain why magnesium is a liquid over a greater temperature range compared to bromine. I have never seen a particle arrangement diagram of a metal in the gaseous state in any textbook. The models that are shown here help me to visualize what might occur when these substances boil and are adequate to support the explanation given in the mark scheme. When both substances boil, it is because enough energy is present to overcome the forces between the particles. Gaseous particles can spread out and are much further apart in the gaseous state than in the liquid state. To address this final part of the question, we can state that the forces of attraction in magnesium in the liquid phase are stronger than those in bromine. Here's the question answered in full. Thanks for watching. I hope you found the video useful. Please post in the comments if you have any questions or suggestions. Take care and good luck with your studies.